This video is brought to you by our amazing supporters over at Patreon. Hey everyone, it's Ben from Board to Bits, and in this video we're going to start creating our system in Unity. So I'm starting a new project here. I'm using Unity 2018.2. You can really use any version of Unity for this particular project. I'm not going to be getting in depth into any new features. You can again also use a 3D or 2D template, doesn't really matter because we're mostly going to be using the inspector and the editor interface for purposes of checking how our game is running. So we're going to create a project. And with our project loaded, we can start creating the scripts. Now there's a couple of approaches we could take here. We could start by actually designing the system, or we could start by designing the units or the nouns that the system is going to use. I prefer to start with the nouns because what happens when you're working on the system is you end up having to break away to create another class for, say, our units in this case, or your maps or characters or something, and then jump back to the system. You're kind of jumping back and forth and back and forth. I prefer to kind of get all of the nouns out of the way so that then when you're writing the system, you can just drop the nouns in where you need them. So our units are actually going to be made up of two different scripts. There's going to be the unit script, which actually implements the actions. These are going to be the things that exist in our world and perform actions every tick that goes by. And then there's going to be a unit profile, and this is going to be applied to the unit that makes that unit what it is, whether it's grass or a rabbit or a wolf. So let's create two C# scripts. First, I will just call unit, and the second, I will call unit profile. And we'll open both of these up in Visual Studio. We'll start by working on the unit profile. And again, this is a collection of settings that is going to actually make our unit into whatever specific entity it's supposed to be. So because of that, it's going to be really easy to work with this if it's an asset that we can edit both at runtime or outside of runtime, and then just apply it like a separate asset to the unit itself. And so for that, we're going to make this a scriptable object. A couple of quick things we'll do to make this easy to work with. First, we need to turn it into a scriptable object by changing monobehavior to scriptable object. And then we can actually create these in the Unity editor by using the attribute above it of create asset menu. Then we're going to give it the menu name equal to, and we'll say something like forest unit profile. Okay, save that. And now from here we can actually start adding the different attributes to our unit profile. All of these will be public because we're going to want to be able to interact with them in the editor itself. So I'm going to delete the start and update methods. We don't need those for a scriptable object. And the first thing we're going to have is the unit type. And this is really going to be whether it's a plant or an animal. This is going to come into effect when, say a wolf wants to eat, it wants to eat an animal, versus when a plant wants to eat, it wants to eat, or when a rabbit wants to eat, it wants to eat a plant. Plants themselves do not actually eat. So what we're going to do is we're actually going to create a variable that's going to be of a new type called unit type. And this is going to be an enum that we create. And I'm actually going to create this outside of the scriptable object class, but I'm going to say public enum unit type. And this is going to have two entries into it, plant and animal. Go. And so now this just sort of acts like a new drop down, if you will, that we have of a selection of options. So here what we can do is we can say public unit type, and I'll give it the name unit type. And again, this is just tracking, is this a plant or animal? And we can even put in a comment there just to clarify what this is telling us. The other thing that's going to be common to all of our units in this particular game is that all units can be eaten, and therefore they confer some sort of level of nutritional value. Hunger goes down by a certain amount when this type of unit is eaten. So, for example, we could say, grass will give you two hunger back if you eat grass, or maybe a rabbit gives you 4, or a wolf gives you 8, things like that. And so we're going to store this in an integer. So we'll say public int nutritional value. We could set defaults to these if we wanted to, or we can just leave them blank. Because these are going to change so much between them, I'm just going to leave them blank, so they'll just go to their default values. From here, we're going to go into the actual kind of adjectives that we're setting up. These were things like the fact that certain things can multiply in every certain number of ticks. They're going to have children propagate, and so they're going to be more of these units created, or the fact that some of them eat. Now we could do these a number of ways. In an ideal, like really modular situation, we would make each of these into their own separate classes and be able to add them individually. For right now though, and if you have a very simple system, it can be quicker just to have them sort of flagged inside of the profile here. So rather than saying, that I'm going to have a list of separate classes that could potentially be attached to this one, instead what I'll simply do is say something like public bool multiplier, which says, does this particular unit multiply? To help clarify this, I'm actually going to add a header attribute here. And this is going to be called multiplier as well. And so this just tells me that all the settings below this header have to do with specifically the multiplier adjective. So there's going to be, does it multiply? Then how frequently does it multiply? This is going to be tracked by every certain number of ticks, we're going to check if this particular unit multiplies. So we'll say public int for the number of ticks, multiply frequency. The next thing we're going to have is that there's going to be a requirement of a certain number of parents. In the kind of obvious biological example of this, one creature cannot, you need two creatures to have a baby. So we're going to kind of abstract that a little bit in how we do the actual numbers, but that sort of idea. We're always going to have a requirement that there must be, some sort of critical mass of these things in order for them to propagate. So we're going to say public int here as well for the count, and we're going to say parent count required. And then the other thing is that when you do have a unit that eats, we're going to also require that their hunger can't be above a certain level. Meaning they can't be, if this creature is starving, it doesn't really count toward the healthy population that would be propagating. So we're going to have a public int called max hunger allowed. And then finally, how many children are propagated when this happens. Again, because we're abstracting this, we might have, instead of it just being a 2-to-1, say, ratio, we might have it that, when there are 6 parents, then 3 children can be created, something like that. So we're going to say public int child count produced. Okay. So with all of those, that kind of covers our multiplier settings. In addition to that, we're going to have our settings for creatures or units that eat. So we're going to have a second header here. Header consumer, I believe, is what we were referring to it as in the previous video. And we'll say public bool consumer. This again will check off if this is actually a consumer, then all the settings below will actually be taken into account. But that's just a flag for us, a way for us to tell, is this unit a consumer or not? And then we'll say public int, and the first thing we're going to have is a maximum hunger value. This is how high the hunger can get before this creature just starves to death. So we'll call that max hunger before death, only because there's also the max hunger here. We want to clarify which is which. Next, we're going to have an integer for how much hunger increases every tick of the game. So again, we're going to use an integer here. We'll say public int. We'll call this hunger increase per tick. Next, we want a certain level. We don't want the consumer to eat automatically, like the moment it gets any hunger at all, it just automatically eats, because then it will never really, things will be eating too frequently, and there's never going to be any downtime for these creatures. So instead of what we're going to do is we're going to have a threshold. We're going to say once your hunger reaches this certain amount, then you start eating. And so we'll say public int eat threshold. And then finally, we're going to want to establish what does this unit like to eat. So we're going to use that. We're going to use the unit type again to say, does this particular unit eat plants or does it eat animals? We're not going to worry about omnivores at this point. So we'll say public unit type, and we'll call this eat preference. Okay. So with all of these here, we can now actually create our, start creating our unit profiles. So let's jump back over to Unity. And I'm going to create a new folder. Called Profiles. And when we open that up, I'm going to right click in here and we'll see in our Create menu, we also now have this forest section, and inside of there is the unit profile that we can create. So I'll click on that, creates a new scriptable object asset here of unit profile. I'm going to name this one grass. And we'll say this is in fact a plant. We'll give it a nutritional value. I actually want these to be fairly high because, again, we know that the hunger is going to be ticking up every single turn. So maybe the nutritional value of a plant is about 20, let's say. Plants will multiply. And we'll say they'll multiply every 5 ticks in the game. There needs to be a fair amount of them for them to multiply. Let's say there needs to be about 6 grass that exists. So for every 6 grass, a multiplication will happen. So if there's 12, then there'll be 2 multiplications. Grass is not a consumer, so we don't have to worry about the max hunger allowed. That's not going to be factored in. But we will have it produce a number of children. We'll say that the population will double whenever there are enough parents. So if there are 6 parents, we want to create 6 children. So really, it has the potential to propagate very quickly. We don't have to worry about the consumer information, so that one's all set. Right click, we'll create a new unit profile. This will be rabbit. Rabbit is of type animal. Now our grass was a 20, so we're going to double that for the rabbit. We'll say that a rabbit gives 40 nutritional value when it's eaten. Rabbits also definitely multiply. They'll multiply a little bit less frequently. Let's say every 10 ticks. They will require a little bit less parents. We'll say 4 parents. Their max hunger that will be allowed will be a little bit of a, this is kind of a, we're going to wait on this one because it's kind of a function of how much their max hunger can be a period. So we'll wait on that one for just a second. And we'll say that when they do produce children, they produce, let's say, 3 children. So they're not quite as, they're not going to overflow quite as much, but they still populate pretty quickly when they do propagate. Now, rabbits are in fact consumers. The max hunger that they can have at all, let's say it is 100. And let's say that their hunger increases by, let's say 5 every tick. We'll see how that works. And the threshold at which they start eating will be, let's say, 25. And their eat preference is indeed plants. Oops. Now that we have that, we can go back here and say that the max hunger allowed for a rabbit to actually reproduce, let's say I think about halfway to starving is probably good for that. So as long as you're not half starved, you're healthy enough to reproduce. So therefore, we'll say the maximum hunger allowed will be 50 for a rabbit. If it's any higher than that, then it will not be factored into the parent count toward reproducing. Lastly, we'll create our wolf. Another unit profile. Wolf. Wolf is also an animal. Wolf will have another very high, we'll give this one, say, about 75 for its nutritional value. Wolves are also multipliers. They multiply the least quickly of these, so we'll say every 20 ticks, these will actually multiply. They only require 2 parents in order to multiply, but they only produce 1 child. So they're a slower propagating, but they're obviously the apex predator. So they could potentially cause more issues. They are also a consumer. We'll give them a maximum hunger of, let's say, 200. Their hunger increase will be about 10 ivory. Actually, we'll keep that at 5 as well, because I want them to get to be a little bit more persistent. So we don't want them, if this was 10, then technically speaking in 20 ticks they would be dead, and that's actually the exact same as the 5 to 100 ratio here for the rabbits. So I'm actually going to make them a little bit more persistent. Again, these are all things that we can come back here and adjust at any time, and that's really the cool part of kind of adjusting your systems, as we'll see, like maybe one thing is overpowering the others, and we can adjust them here. But yeah, we'll say a 5 increase to 100, so they last a while, and then their eat threshold will be around 100, again halfway to death. That seems fine, and they have an eat preference of animals, not plants. Now the maximum hunger allowed for them, oh wait, that's right, the E threshold is actually lower. The E threshold we'll put at like 50. It's their maximum hunger that'll be halfway between full and death, so we'll put that at 100. Okay, so that gives us all of our stats that we have created in our unit profiles. Now we can start to create our units themselves. So if we open up the units, we do want these to be monobehaviors, because these are actually going to be created and we want to see them in our hierarchy so that we can actually track how many there are and what their stats are. Now these are actually going to be the kind of physical manifestations of these profiles. So what we want to do is we want to have a slot in our units to say, based on whatever unit profile is here, this is what I am. If I have a wolf profile, then I am now a wolf. If I have a rabbit profile, I am a rabbit. So the first thing we'll add here is a public unit profile, and we'll just call that profile. And that's really going to be the identity of what this is. We're also going to want eventually there to be a link to the system itself. So I'm going to put this as a to-do right now because we haven't obviously created that, but we'll say forest system variable. We're also going to want an integer to track the current hunger. The profile, as we see, shows what the max hunger is for reproducing, what the max hunger is period, but it doesn't actually track the individual hungers for each thing. That's going to be handled by the unit itself. So here we're going to say public int current hunger. We're also going to give it a public string called base name, and this is going to be kind of like what its type is, as well as which particular one has been created. So the very first one would be, say wolf 0, the second wolf 1, wolf 2, etc. So we can keep track of who this is. There's a reason I'm actually just keeping this in a separate variable and not just using the name of the monobehavior itself, and we'll see that as we start creating our system. But I am going to store that in a separate space. Next thing I want to do is this a quote-unquote healthy unit? Is this a unit that can be considered for when we're multiplying? And so we'll do that with a Boolean. We're going to say public bool, and we're going to make this an accessor. We're going to call it is healthy, and it is going to get return. And we're going to check one of two things. Either A, is it not a consumer? If like grass, for example, is not a consumer, it doesn't have a hunger, so it's always healthy. So we'll say if not profile.consumer, meaning if we check into the unit profile and consumer here is false, then it's just automatically healthy. Or we need to check that its current hunger is less than the profile.max hunger allowed. If this is true or this is true, then it is considered healthy. Otherwise, it is the unit is hungry and cannot be used toward reproducing. The last thing we're going to do, I'm actually going to delete these two right here for now. We don't need them. Is we are going to create, though, kind of like a start method, we're going to create an initialize method, which we can pass in some information to. So this is going to be when the system creates one of these units, it's going to pass in the unit profile, and from there it's going to kind of create this unit for us. So we're going to have a public void initialize, which is going to take into it a, unit profile parameter. In here for now, we're just going to do a couple of things. We're going to expand on this as we build out our system, but for right now, we're simply going to apply the profile to the unit itself, as well as setting its name. So we'll say this dot profile, meaning the current instance of the unit's profile, is going to be equal to the profile that we're passing in as the parameter. As well, the base name of this unit is going to be equal to the profile.name. So for right now, the base name here, this string, will take whatever the name of the profile is. So it'll take grass, wolf, or rabbit. Obviously, we want to add in that number of how many have been created before it, so we know which one this is. Is this rabbit 5? Is this grass 17, etc.? But we'll be adding that in as we build out our system a little bit more. But for right now, we have kind of the basics of the unit profile and how we take these settings here and turn them into an actual unit that's going to exist in our world. In our next video, we'll start building into our system itself and showing how these units interact with that system. In the meantime, thanks for watching, and I'll see you next time.